Okay, so let's give it a try. So let's try number 8. Let's start there. Since that's the last one not done. I'm going to try to go kind of fast because that way I get as many as possible on the recording and you can go back and slow them down if I'm going too fast later. So I'll probably pick up the pace a little bit here. So try number 8. What do you do when you see an x squared equation? Get a 0. Good, good. So that game plan's got to be real clear in your mind. Sounds like it is for a lot of you. Yeah, when you see an x squared with an equal sign, step 1 is get a 0. And when I say that, you want to get everything to the side where x squared will be positive. So I'm going to jump both these guys to the left. Is that big enough? Can you see that? I can make that a little bigger, I guess. Okay, yeah, so when you see x squared with an equal sign, step 1 is get a 0. So I'm going to jump these guys this way, so I'll get 4x squared plus 3x minus 10, right? They change signs when they jump to the other side. So you move everything. Why did I move everything left? Why didn't I just move that 4x squared to the right? Because he would have been negative. It's hard to have the front turn negative. It's just difficult. I mean, you can do it. It's not the end of the world. But step 2 is you can try to factor if you want to. Some of you are probably really good factorers. And if you want to, you can just factor it. And that would be quicker, actually. If you're a really good factorer, you can just factor that thing and you'll be done. I've found over the years that sometimes it's easier for students if I just do the quad. So I'll do that. So I'll say, or you could use the quad. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That good like that? So this is a, b, c. And just plug right into the quad. So here we go. Negative b, negative 3, plus or minus the square root of b squared, 3 squared minus 4, times a, which is also 4, times c, which is negative 10, all over 2a. So coming on down, it's negative b plus or minus square root of b squared, 9 plus 160. Does everybody see what happened there? 2 negatives made positive. 4 times 4 is 16 times 10 is 160. Keep going. Minus 3 plus or minus the root of 169 over 8. What's the root of 169? 13. So what do we have? We have 2 possible answers now. Minus 3 plus 13 over 8. And minus 3 minus 13/8. That's 10/8, which reduces to be 5/4. And the other one, minus 16/8, which is negative 2. So negative 2 and 5/4. There it is, D. Good on that? Remember x squared equations? Get a 0, try to factor, or do the quad. If you factored it, that would have been even quicker. Questions? Okay.
Is that a 216?
What's that?
Is that a 216?
Yeah. It's a 2 there, yeah, 16. Oh, yeah, why did I make that a 2? It shouldn't be a 2. It should be an 8, thanks. Good on that. I'm getting a little scribbly. When I go faster, my writing gets even worse. There we go. All right, so anyway, there we go. So try that one. Seems like it's working now. This is kind of tricky. You remember this graph? We don't deal with him a lot. He just comes up. He's one of the original 6, but we don't see him a lot. He's the one that has the 2 asymptotes, one right down the center, one right there, and one branch is here, one branch is here, unless it's been flipped. See, that one's been flipped. That's how it starts over. That's the 1 over x, right? It normally has the first and third quadrants. But this one's been flipped. You could actually flip it either way. You could flip it vertically, and this guy would go up here, and this guy would come down here, or sideways. It would do the same thing. I don't know if you ever thought about that one. That one, it's the same thing to flip sideways as it is to flip vertically. But if you flipped it sideways, this guy would go over here, and this guy would go over there, which is the same result as if you flip vertically. Either way, same thing. Why is that? Because it's the same thing to put a negative in the front, which is a vertical flip, as it is to put a negative right on the x. That's the same thing. It's the same equation, same picture. Notice the beautiful agreement between equations and pictures. If it's the same in the equation, it will be the same in the picture. So anyway, long story short, it's the 1 over x graph that's normally in the first and third quadrant that's been flipped. And it looks like it's been moved to the right, because normally that vertical is, right in the middle. It's been moved right 1 unit. So it's been flipped, vertically or horizontally, either one's the same, and it's been moved right 1 unit. So it's this equation been moved right 1 unit. Well, they've all been moved right 1 unit. They have x minus 1. So that's good for all of them. That makes that vertical asymptote x equals positive 1, doesn't it? Right there. That would make the bottom 0 for any of those. That's correct. That's where the vertical is. Now, well, how do we go from here then? They all have that. Well, what else do we do? Well, which ones have been flipped? Which ones do you see a flipping action on? This one has a minus 1. This one has a minus 2. This one has a minus 1. Those are all flipped. A is out. See how those all have a negative number? Multiplied or divided. Do you understand what I mean by that? When you put negative 2 over x minus 1, that's the same thing as negative 2 times. Remember, to be up top is to be in the front. Those are the same, aren't they? So to put a negative 2 in the top of a fraction is the same thing as multiplying the whole fraction by negative 2. So that's why when I see that negative 2 up top, I say to myself, multiplied by negative 2. On part C, I say multiplied by negative 1. On part D, I say multiplied by negative 1. So all those are flippers. So they're all good. They're all going to do the flip thing. So I'm down to 3 options. And of course, it could still be none of the above. How do I know which is right from here? I don't know. I would do a point at this point. I'd plug in something, some kind of point thing. So let's do that. So remember how to find the new center point? You plug in what will make x's little world go to 0. Well, what's going to make all these little x world 0 is 1, huh? If I put in 1, 1, 1, it'll make any of them 0. Let me just take the top equation, b here. Y is negative 2 over x minus 1. I'll just start with him. If I plug in 1 there, I'm going to get negative 2 over 0. And what's that? What's negative 2 over 0? Yeah, that's a no-go. That's a vertical asymptote. Let me just write that way instead of no. I should say that's a vertical asymptote, isn't it? Of course, we know that already. It's got a vertical asymptote at 1. That's not any new information. How about this point? Look at him. He should be an easy one to find. I'm just going to look for something easy that's obvious and clear and central on the graph. That's the point over 0 up 2, isn't it? So the real winner will have the point over 0 up 2 on its graph. So how do we know which one that is? If I put in 0 for x, will it work for this equation? If I put in 0 for x, I put a 0 right there. What am I going to get? Negative 2 over negative 1? Yeah, positive 2. It looks to me like B is correct. Would that not have worked for C or D? If I put in 0 for x, I'm supposed to get positive 2 for y, right? 0 for x, positive 2 for y. If I put in 0 for x there, I would get negative 1 over 0 minus 1. So I'd get negative 1 over negative 1, which is minus 2, which is positive 1 minus 2, which is negative 1. No, that's not right. See how that's not right? When you put in 0, you're supposed to get 2. 0, 2. So C is not right. When you put in 0 here, you're going to get 3. Does everybody see that? Negative 1 over negative 1 is positive 1 plus 2, 3. That's not right. You're supposed to get 0, 2. So B is the winner. Not okay? A little tricky with the points there at the end. All right. Let's keep going. Okay, so number 10 is an exponential graph. Do you remember what the deal is with exponential graphs? We have a general form for exponential. Let me just write it out again. If you have, what did I write? B to the x plus a. That plus a, that's the horizontal asymptote, isn't it? And the graph goes up. Well, I'm not doing that very. It's supposed to. Yeah, let me try that again. It's supposed to come down for a landing at that A spot, and then rocket up. So rockets on one side, flattens out, comes out for landing on the horizontal asymptote on the other side, unless it's been flipped or something like that. Okay. So, if that's our so this, what I'm saying is, this is probably what you want to have on your full sheet of notes for the final tomorrow, is have the general roadmap for graphing exponentials. So, first off, where's the horizontal asymptote?
+2.
Yeah, this is at +2. So that means we need a positive, not a +3. B's out, D's out. You don't want +3 out there, you want +2. Okay, now, where are we going to go from there? Well, has this graph been, looking at A and C, has it been flipped? And if so, how? So again, the normal one goes up to the right. They all go up to the right, normally, don't they? All these graphs start by going up to the right. Has it been flipped sideways or vertically? Vertically would make it go down. Remember, vertically would be, like that. So it's been flipped sideways because it's going left instead of up left. It's still going up, so it's not going down. It's not vertical, but it's up left instead of up right. So it's been flipped sideways. So what makes a graph? So sideways, flipped sideways. That's a negative on the x, huh? Negative on the x. So C is looking good, isn't it? We can check it with a point. Not A. A has negative in front. That would be a vertical. That'd make it go down, wouldn't it? So not A. C has the negative. So let's double check. How can we double check C to make sure? We take y equals 5 to the minus x plus 2. And remember what you do. You plug in a point. How do you decide that first point to plug in? Basically, you're trying to find the new center. You plug in what will make x's world 0. So right there, you're going to plug in x is 0. What do you get? 5 to the minus 0 plus 2. 5 to the 0 power? 1 plus 2, 3. So over 0 up 3, yeah. Over 0 up 3 is on the graph. That's enough for me. It's looking good. You can do more points if you want, but it's got to be C. Is that good? On that one? Questions? Okay, so let me give you the roadmap, the template for a log graph. For a log graph has remember it has a vertical, so it's the opposite of exponential. Exponential has a horizontal asymptote. Log graph has a vertical asymptote. Back at negative A, remember that? When you have y equals log base b of x plus a, the opposite, because remember x is always opposite, opposite is the vertical asymptote at x equals negative a. And then the log graph takes a dive right at the vertical and then goes up to the right, concave down, slow growth. Opposite of exponential, which is rocket growth. Okay, so there's the general template. Notice it's in parentheses, huh? It's the number in the parentheses that's the x effector, makes that dotted line go the opposite direction. So look at our graph. Look at the one they're giving us. Where's the vertical asymptote? They're not putting the dotted line on the graph, but you can tell where it is because it's right where the graph takes a dive. So it's right on the axis, isn't it? Because the graph is taking a dive right there. Huh. So it's right at x equals 0. So what that means is there's 0 in the parentheses, meaning there's nothing in the parentheses. There doesn't even need to be parentheses. There's just log base b of x. Nothing in x's world with it. 0. So no way on B, no way on C. See how they have numbers in the parentheses with x? That would move the vertical asymptote. That's not right. It's not been moved. It's centered right at 0. So there's nothing in the parentheses with x. You realize that A and D are still candidates. Like D, you might think, well, that minus 2. No, but that's not in the parentheses, huh? And we've learned it makes a big deal of difference whether you're in the toaster or not in the toaster, right? That's really different. So D is not in the toaster. This is out. What is this minus 2 going to do? That's going to be down 2, isn't it? That's a y effector that's not in the parentheses. So how do we know which one's really right or what? Well, has this log graph been flipped in any way? Normally they go up to the right. They always normally go up to the right. What's ours doing? Up to the right. No flips at all. Might have been moved, but it's not been flipped, has it? So no flips. So that should be no negative multiplying x or negative in the front. So I'll say no negative in the front, no negative multiplying x. No negative multiplying x, no negative in the front, multiplying the front. Right? Because negatives multiplying the front are vertical flips. Negatives multiplying x are sideways flip. We have no flips at all. So A is out. See how he has a negative, whoops, right here, in the front of the log? See how he's not right? He has a negative multiplying the front of the log. So that's not right. We've already got B and C out. So it's D or nothing. D's looking good. That minus 2 is a down 2. It looks like that log's been moved down 2. If you want to check a couple of points, you could. So if I wanted to come up here and get a little bit of room here. If I erase that too fast for you, it'll be on the YouTube. Okay, so y equals log x of 2. I'm thinking that's probably it. Let's double check. What could I plug in? You could plug in, well, 0 is going to be the vertical. You could plug in like 1. If you plug in 1, get log 1 minus 2. If you do that in your calculator, log 1, it'll be 0. 0 minus 2, negative 2. Over 1, down 2. Yeah, that looks perfect, doesn't it? Over 1, down 2. Yeah, it's looking good. That's got to be it. Good? All's well on that? It is D. Questions? All right, so I'll move along. It'll be on the while since we've done these kind. How do you solve, what about that? Any thoughts?
Make the bases the same.
Yeah. Could we, yeah, I got to make the bases the same. You could do ln. You could do ln. It'd be easier on this one to make the bases the same, but ln is okay as well. Either way, I'm going to just make the bases the same, be the easiest way to go. So if I make these bases the same, then what can I can make them both 3. What do you do with 1/3 to make it 3? 3 to the negative 1 to the 5x plus 6, right? That's the same as 1/3, right? Remember, negative powers flip. And the 9, that's 3 squared to the x minus 2. Does everybody see how I made them both a plane 3? Right? 1/3 is 3 to the negative 1, 9 is 3 squared. Is that good? And now that you've made the bases the same, you can cut out the bases. Negative 1 times 5x plus 6 is 2 times x minus 2, right? Because if the bases are the same, then the powers have to be equal. Otherwise, one base to the power wouldn't equal one base to the other. If the powers were different, 3 to one of them wouldn't equal 3 to the other. Powers have to be equal. Distribute. Minus 5x minus 6. Distribute. 2x minus 4. How do you get x alone here? Subtract 2x from both sides. What do you get? Negative 7x minus 6 is negative 4. Add the 6 to both sides. Negative 7x is 2. Divide by negative 7. Negative 2/7. Is it not there? It's disturbing, isn't it? There it is. Hopefully I didn't mess up. Good there? Questions on that one? Onward we go. Okay. Can you see that okay? So there's the function up there. Can you find the vertical and horizontal asymptotes? So, okay. So graph by finding the vertical and horizontal asymptotes. So let's start with the vertical. So how do you find vertical asymptotes? What makes a vertical? Denominator 0, right? Because it's 0 on the bottom equals 0, so that would be x squared minus 3 equals 0. How do we solve that? Yeah, just move the 3 over, add 3 to both sides, so x squared, I'm going to move it over here. So x squared is 3, and then roof on the house, up and down the ladder. So x is plus or minus 3, which is root 3, I mean, which is 1.7. We did that one a minute ago. So they've got to have vertical asymptotes at positive and negative 1.7. Well, that's C or D. A and B are out. Right? You can tell. Now, they're not showing the vertical, but you can tell they're there. You can tell there must be a vertical right about here, because that's why the graph is rising and falling right there and right there. See how just a little to the left, a little to the right, just before 2, 1.7, makes sense. It's doing that. Same thing on D. D is as well. So C, it's got to be either C or D. There's no E on this one. There's no E. So it's either C or D. A and B are out. They don't have the right verticals. Now, C and D have different horizontal. Remember, we went over this problem. It was just a couple weeks ago. We went a lot, though. So one of them has a horizontal asymptote above. One of them has a horizontal asymptote below. So the horizontal asymptote will decide the answer for us. How do you find a horizontal asymptote? Remember, I gave you a whole table. I said it's numerator power. I wonder if I can squeeze it in here. Yeah. So I said, look at the numerator power. What's the numerator power here? 2. The denominator power 2. Yeah, there's about 2 for both. So I said if the if the denominator power is bigger, then it's y equals 0, horizontal, y equals 0. If they're equal, it's a over b, where a and b are the numbers in front, right? If the numerator is bigger by 1, it's a diagonal or oblique. And number 4, if the numerator is bigger than the denominator by 2 or more, there's no horizontal, no diagonal. So you can put that on your 3x5 card. So what's our deal? They're equal. The numerator and denominator are equal powers. It's all about the most powerful term, top and bottom. So it's what? R's are equal. Numerator equals D. 2 equals 2. So then you take this case, y equals a over b. What's the a and the b? It's the number in front, the coefficients. Because the x squareds are going to cancel. Right? You're going to get x squared over x squared with the 1s. They cancel. It's 1 over 1. Y equals 1. Positive 1, that is. So it's D, huh? He has the positive 1 horizontal asymptote, not negative. So D is the answer by finding vertical and horizontal asymptotes. Remember all that about asymptotes? Questions on that? All right. All right. Can you solve number 14? All right, here's what I'm going to do. Let me do that. So 5 plus 3 ln x is 12. X is saying I want to be alone. So what do we do to get x alone? Subtract 5. And so we get 3 ln x is 7. Divide by the 3. Right, we're just peeling the onion here, right? Go from the outer layers in. So far, so good. I just started the outside. I just keep peeling the onion. I'm down to here. What do I do now to get rid of that ln? Do I just divide by the ln? It's not multiplication, right? It's in the toaster. It's ln of x. How do you get rid of that ln? The inverse function, which is e. Getting the hang of that? That's how we get rid of those. That'll help you in calculus. Okay. So, yeah, and I do e to the power. It's not just e times it. That's the other mistake I see a lot of students make. Remember, ln is reverse of power, not of multiplication. So in other words, it's not e right next to it. E right next to it. It's e down here is the power. Is the base with whatever's there is the power. So these cancel. X is e to the 7/3, and that's D. Good on that one. And then 15. That over here. So 15. E to the x plus 8 is 4. So what are we going to do? ln of both sides, huh? So we're going to say, okay, ln cancels the e, doesn't it? So then we get x plus 8 is ln 4, and then subtract the a, ln 4 minus 8. There it is, a. All is good. I'll keep moving. Questions on that one? Okay, so let's try number 18. 3 to the x is 17 to the x minus 2. You see all those natural logs in the answer, so you know we're going to do natural log, and that's what gets rid of the e, so let's do that. Natural log on both sides. And then, it doesn't cancel. Whoops. Natural log only cancels e, huh? So what does it do here? Well, the powers come down. Remember the whole powers come down? For any log, really. You could do regular log on this one, too. When you do log, they have that quality, that third property, the powers come down. So you get x in the front, and you get x minus 2 in the front. Right? Now, why did I put parentheses around that x minus 2? Because that way the whole x minus 2 is multiplying, because the whole x minus 2 was the power, so that's true to the property. So now's where it gets sticky. That part I think you're real comfortable with. Now's where it gets a little hard. It's a little tricky. This comes up in calculus a lot, where you got this kind of thing, so let's go through it. So this guy, remember, ln 17 is just a number, so it's got to distribute. So we get x ln 17 minus 2 ln 17. Okay, what should we do now?
Good, x is on the same side.
Good, yeah, so this will come up a lot in calculus. For sure going to be one of these in the final. X in two places, get them on the same side, factor it out, and divide. Let me write that somewhere. X in two places. What do you do? Number one, get the x's same side. Factor out x with the parentheses and divide. That's the game plan. So I'm going to subtract x ln 17 from both sides. Gonzo from there. So then I'll have x ln 3 minus x ln 17 equals minus 2 ln 17. And then I can factor out the x. Take out the x, ln 3 minus ln 17. And last step, divide. Boom. There it is. So hopefully it's one of those answers. Is it D? Looking kind of like D to me. Let me double check. Yeah, looks like D. Is that good? Now remember, they can give it a different look. If they happen to move the x's the other way, it would just end up looking different. Do you remember that on the multiple choice? I'll write same as what? Positive 2 ln 17 over ln 17. So does everybody see that? Do you see how that one worked? Try number 19.